Practice test is on Manage Back, so you can get started just right now. I just want to go run through a few things just to help you out a little bit. This practice exam is, first of all, longer and a little bit harder than the actual exam. So do bear that in mind. So I just wanted to put in a few extra questions just to give you extra practice. Just going to run through what you might need to do with each question just to help you out. So this first one, this is a trigonometry question. You're going to have to use sine, cos, and tan for this. Sine, cos, or tan, you're going to have to use those ratios for this first question. Okay, to find both the length of BD and this angle here at C. You're going to have to use that. Question 2 asks for lines of symmetry. So remember, lines of symmetry, that is where you can cut a shape so it folds perfectly on top of each other. So that's lines of symmetry. So you just have to say the number of lines, number of times you can cut this shape. And rotational symmetry is if you spun this shape around, how many times would it be in the exact same position if it did a full 360 spin around the spot? So if it did a full 360 spin, how many times did it reach that place again? Did it look like this again? For question 3, maybe if you can't remember, we need a name for this shape. So it's a net. And then you need to find the perimeter of the net. So that would require you to use perimeter is going to be all the outside of the net. It will require you to use Pythagoras' theorem to get the exact length of here and here. So remember to use Pythagoras for here. Okay, to get that length, you're missing a length there. Although you can just count the boxes for the other ones. Question, the rest of C then, work out area of a triangle, so half the base by the height. Volume then, so once you have the area of one of the triangles, you can just multiply it by the height. Part D then, so this is the cuboid, so that's a shape like that. Length 4, 3 as the same volume. So you'll have a volume from this question. You have to apply it here, and you're missing one dimension. So remember, it's 4 times 3 times something is the same volume as there. So you need to work that out. Question 4 then. The first thing they ask for is the gradient of this line. So you're going to have to put in a triangle somewhere and count the boxes. Remember, rise over run. So you count the boxes up and you count the boxes across and rise over run. That's one way of doing that. And then write the equation as y is equal to the gradient times x plus c. So c is where it crosses the y-axis, where this line crosses the y-axis. Part B brings in a bit of algebra. So this was from the last unit. So you just have to complete this table by subbing in these points and then draw the graph. So on this same graph you can draw it. If you don't have a printer, you're going to have to sketch this out. And then use your graph to solve where it equals 0. So in other words, where it crosses when y is 0, so where it crosses that x-axis. Okay, I should have 2 answers for that. And then find the coordinates where the one you've drawn meets the one that's already drawn. So there should be 2 places where they meet, and then just put in the coordinates of those points. All right, question 5 then is transformations question. So it asks you to reflect first, so that's when it's looking in a mirror in this line, so somewhere over there. Rotate, so that's where you're going to need to get a piece of paper and do a rotation. Piece of see-through paper, do a rotation, so draw it on. Part B then asks you to describe a single transformation that maps P onto Q. So you can clearly see that it's got larger. So what type of transformation is that? Remember to give a center of that transformation as well. Where is it coming from? So you're going to have to draw, well, if you have a printout, you can just draw the lines or you can estimate the lines. And flag P to R. So P to R, that looks like a move. So what's that called? When we move like that, and how do we say it? This doesn't look right. Okay. Oh, it is, yeah. All right, so next bit. So this is polygons. So what we did the other day. So name the polygon with 3 sides. Okay, I should know that one. 5 sides and 8 sides. They give you those. Okay. This is a little bit of a polygon and a regular nanogun. So it says nanogun has 9 sides. That should tell you that's the external angle or exterior angle. And then you need to know the interior angle. So that's exactly what we did in class here today. So if you want, you can rewatch that video. Question 6 is your bearings type question. So we've done enough of those. I'm sure you can give a good go at that, and I'll give you the answers to that next week. And then it's more bearings and a bit of speed put in here, and then a distance at the end. So it's all very similar. Constructing another point. It's all very similar to the questions on bearings you had before. Question 7 asks you to find a surface area. So this is back to just areas and volumes. So surface area. So you have to get the areas of all these surfaces and add them together. Get the volume. So that's same. Get the area. The area. Well, it's it's length times width times height. That's an easy one. Then you have to do the volume of a cylinder inside this. So you have to get the volume of a cylinder. You might need to look up that. It's going to be the area of the circle. So pi r squared, and then times whatever distance it is back. So that'll be the volume of that cylinder, the height back. So pi r squared. Remember, that's the diameter, not the radius. And then I'll leave you to figure out that one. And I'll leave you, these are all just follow-on questions from that. Surface area of a cylinder, you might need to look that up if you can't remember how to do it. Something to do with the circumference. And then question 8 is just one of our transversal questions. So can you figure out, calculate the value of x? Ooh. So it's all about maybe perhaps adding up to 180 or something like that. And the last question then is our circle theorems. So this is circle theorems, and we've done enough of those, and it finishes off then with a trigonometry question again. The last question is trigonometry. Okay, so as I said, a lot longer than the actual exam would be, but I tried to cover almost everything that could be on the exam just to help you with your revision. I'll put that recording of what I just said up on Manage Back soon.